Hello, welcome guys. Today I'll be presenting a water flow project that calculates the water flow and the concentration levels within a given area. Before we begin, let's inspect what a user will have to input into an Excel sheet so that the program can work. So as you can see right here, there are 5 tabs that the user will have to work with. The first tab is actually the boundaries of the pressure heads. So for example, the ones it identifies it as an active point, which actually will be included into the calculations of the actual code. The next tab is the pressure heads, and in this case, there are 3 steps in the pressure heads, meaning that there's 3 different changes in this type of pressure heads. So for the first step, it's a well with a negative pressure head. The second one has a positive pressure head, and the third step has a bigger positive pressure head, which is actually pumping in water into the system. Now for the contaminants boundaries, you can actually see that it's very similar to the heads boundaries. And now for the contaminants, you see that you have a contaminant right here, which will spread out as the water flow moves around. The time tab gives us the times that the user wants to input. The user has the responsibility of inputting these times, and these basically 0 stands for time 0, 30 times, and whatever unit of time. It could be days, months, weeks, for example, hours. It depends on your unit of time. The last times inputted will always be known as the last time in that final step. Everything before are going to be the start times of each step. So obviously the start time for step 1 would be 0 because no time has passed. And it is very important that in the head boundary steps and the head pressure heads that there's a line that is skipped, because the code depends on the skipped line for the code to be able to know which step it's looking at. So now that we looked at this Excel sheet and what the user has to provide, we can go ahead and run the code to generate the GUI interface. The user will load the input file, which is the one we just saw. And once it loads, you can actually see the values for the first step right here. The values you will have to input are the permeability, intrinsic permeability, delta X and delta Y, the change in time depending on the unit of time that he wants, and the porosity of material D and B. So just for this quick example, I'll put in some values so we can see it in action. Our change in time will just be 1. The porosity would be 0.55. And D will use 0.01. Once you have your values and your input file, you can calculate the flow rates and contaminants. On the lower left corner, you'll see the water flow at this step, and on the lower right, you can actually see the contaminants spreading out every time the time changes. And what you're seeing, why it grows and it comes back in, and it grows and comes back in, is because it actually runs it for all the steps. And if you want to see the final contamination at each step, it shows it right here in the center plot. So for example, concentration at T equals 29. We said that the Excel sheet that the first 3 times inputted were going to be the beginning of the next step. So it's logical that subtracting 1 is going to give us the last step, the last time of that step. And that's why we have concentration of T equals 29. If you press for the next step, you see that the water flow changed, and you actually see the concentration. You see the concentration wants to move back now. And again, it's still here. You see how the concentration changed. And now that you have all your data, you can save it in an Excel file. It automatically saves it to file_data, but you can change it to whatever you want. But for now, we'll leave it as this and see what we saved. Now we can go to the folder that we were working on, and it should be right here. So this is what the file saved. We saved the value of k, which was 30 when we inputted it. We also have the boundary conditions here that it had. So like I said before, 1 is active, 3 we consider a corner, 2 is called inactive, 6 is a no-flow boundary, 4 would be a constant boundary that won't change. And we actually saved the pressure heads right here, which was the final step at 2000. Moving on, we saved the actual flow rates at that final step. We also saved the velocity x components and the velocity y components of the water flow. Another feature about this GUI is that you can play back the contamination in a 3-second video by hitting replay. This concludes our project. Thank you.